Mic on? Cool. All right, so welcome everyone. My name is Kenneth Hjelmer. I work as a consulting architect at a company called Aria in Denmark. In this session, we're going to go through an infrastructure automation project that we've made with one of our public sector customers. From the initial pain points experience to the technical solution we ended up implementing. So for reference, the customer is located in Denmark. Denmark is a country that has around 6 million citizens and is separated into 5 different administrative regions. Region Nordjylland, or in English, the northern region of Jutland, is one of these 5 administrative regions. Denmark consists of 29 municipalities, of which 11 of these form the administrative region of Northern Jutland. The main responsibility of the regions is healthcare, public transport, environmental planning, and coordination of education. The region employs around 220 people in IT, and the current infrastructure consists at about 100 ESXi hosts and 2,500 virtual machines that are hosted in different highly available Tier 4 data centers across the region. So the customer contacted us to initiate an infrastructure automation project to help them realize the benefits and value of infrastructure automation. The initial challenges that led to the project were that servers were often created by hand by different people, leading to inconsistent or different server configurations. They also often needed to reallocate resources to other strategic IT projects. The delivery time for servers would impact productivity and with the risk of introducing shadow IT. CMDB was often not up to date or incomplete and not consistently maintained. Lastly, agents and antivirus software often either weren't deployed or were misconfigured. So their main goal was to standardize their platform and deployments to ensure a consistent deployment across the entire infrastructure. We wanted to introduce self-service to offer service owners a way to deploy their own resources when they needed them. We wanted to decrease time to delivery, while the existing deployment time was generally accepted by the business. They wanted a solution that could satisfy both current and future requirements. Automating ITSM and CMDB tasks as part of the deployment process were to make sure that the internal guidelines were followed. And they needed a way to enforce the configuration of virtual machines by making sure that SCCM would always configure these virtual machines. So if you take a look at the service request process, the way it looked when it started out, if you as a service owner needed a virtual server, you had to request it by creating a ServiceNOW request, upload an Excel sheet, and then you wait. At some point within the SLA, the infrastructure team picks up the request, assigns an owner to it, and begin processing it, verify that the required information is there. When the person assigned to the incident begins to process it, the provided data might be incorrect or needs to be reassessed together with the requester. Once all is in place, the server is installed and configured, often by hand, cloning from templates, installing agents and other software, while manually maintaining IPAM and CMDB in the process. And finally, the server is handed over to the requester and the request can be closed. So ordering a server could take days. The solution was to implement Aria Automation with the integrated orchestrator. This provides the server owners with the ability to log in and request service and resources 24 hours a day, 7 days a week. Aria Automation provides it with Active Directory integrated self-service portal to request the resources. It also acts as an infrastructure as code endpoint. Aria Automation Orchestrator executes pre-built workflows, among others, and integrates with external systems through built-in plugins or REST API that is tightly integrated with the VMware ecosystem. So the primary goals they wanted to achieve by implementing this new platform was to set up guardrails to make sure that users couldn't just request a server with a terabyte of RAM and 256 CPUs, at least without approval, and to make sure that the inputs in the request form was validated. We wanted to make sure that they deploy from a centrally maintained vCenter virtual machine template to establish a uniform and standardized server infrastructure. Then we needed to make sure that all agents were installed and registered correctly every time, and if installation failed, the entire deployment would have to fail. They wanted a way to apply tags and custom attributes to the virtual machine to be able to see who would be a service owner if you wouldn't have access to ServiceNow. Creating and closing standard changes as part of the deployment when the deployment was completed, and to create the CIs. We needed a way to enforce naming standards, implement approval workflows where needed, so if you requested a large server, the server would automatically request approval from management. We needed to make sure that we always configure and manage virtual machines using SCCM. And lastly, reduce time to delivery. So the deployment process was redesigned for deployment using Aria Automation, and the resulting workflow would look like this. The server owner would now log into the self-service portal to order the server, providing the relevant data in the form. Data input would be validated using orchestrator action and regex to make sure that the inputs were valid. A pre-approved standard change is created in ServiceNow using the ServiceNow REST API from Aria Automation Orchestrator. Virtual machines are deployed from a verified and centrally maintained template. As part of the configuration, we make sure that all agents are installed. By installing an SCCM agent that points to a task sequence when we run it, we install all the required agents and software as part of the deployment. CIs are created in ServiceNow, and the open change is closed. And finally, the server is handed over to the requester that receives an email saying that his server is now ready for use. So this solution is built on Aria Automation, but is heavily relying on Aria Automation Orchestrator for the execution and external API integrations. The main server deployment form, the request for Windows Server, was split into 3 different parts. I know it's in Danish, but I hope it will make a little sense anyway. The first part lists the different information that help us build the host name. This is derived directly from the naming standard. Most of these data are pulled directly from ServiceNow, for instance, the related business service. This generates the base host name. The hashes are an indication that is used in Orchestrator to tell Orchestrator to find the next available host name. The second part contains the data we need to configure the virtual machine. The requester provides a vCenter folder, an operating system, a t-shirt size, whether he wants additional disks, IP information, domain, and so on. And the third part of the form contains the administrative data. These are the data that we write to the custom attributes in vCenter, as well as the server owner and assignment group that is being used in ServiceNow. In the UI, we use Aria Automation Orchestrator to provide us with live data from external systems using orchestrator actions. In this form, we list the users of an assignment group in ServiceNow. This is retrieved using the ServiceNow REST API that provides us with the service owner's sys-ID in the background that we don't see here, that we use later to assign the server owner to the CI in ServiceNow. Using external data this way ensures data quality and minimizes typing error. We try to use as much external data as possible. So here's how it looks when the service owner requests a new server. We start by selecting the server we want to deploy, in this case a Windows server. The first set of data we need to be filled out are all dynamically pulled from ServiceNOW using REST API. They all contribute to building the host name based off the naming standard that we talked about before. Next, we need to provide the vCenter folder, the operating system, the additional disks, network, IP addresses, and so on. We select the operating system from a predefined list that correlates to a specific virtual machine template. We can provide up to 3 additional disks of up to 300 gigabytes of storage each before needing approval. We select or search for the port group we want the virtual machine to be attached to. And provide the IP address and corresponding subnet mask. If we want the server domain joined, we also select the desired domain. And lastly, we fill out the information that is presented in the custom attributes UI, as custom attributes on the virtual machine. This is the speed that the REST API is returning data. When the form is submitted, a validation script runs to verify the validity of the data. In this case, the IP address was already in use in vCenter, so we need to go back, edit our inputs, and resubmit it. As soon as the deployment has completed successfully, the user receives an email with the details on his new server and information that it's ready to use. In ServiceNOW, the auto-approved standard change has been created, description has been added, and eventually closed again. The CIs has been created, linked to the business service, assignment group, and service owner. Description has been added, and the relations of the CIs has also been updated. The secret to interacting with the external systems is the integration with Aria Automation Orchestrator. This is a list of events that is triggered in Aria Automation, in an Aria Automation deployment. In Aria Automation, we have the option to subscribe to events and to hook that event to trigger orchestrator workflows. When the compute post-provision event is triggered, the virtual machine is fully deployed and ready for customization. So we pause the deployment, instructs orchestrators to run a workflow that logs into the newly created virtual machine through VMware tools, install the SCCM agent, and run the SCCM task sequence. Orchestrator will then wait for SCCM to finish the installation before returning to the deployment. This is the same process we use when we create ServiceNOW standard changes. When the workflow runs, it will initiate an unintended install of the agent through VMware tools. The installation file is already present in the template, and pointing to a task sequence ID will instruct SCCM to run it immediately after the installation is complete. The SCCM task sequence will install all the standard software, agents, and configure the virtual machines as needed. If the task does not complete successfully, the entire deployment will fail and the user has to start over again. We don't want virtual machines not configured by SCCM to enter the infrastructure. So what about decommissioning? When we delete a server in Aria Automation, we want all the related tasks to be included to fully decommission the server. We created what's called a custom resource action in Aria Automation that we present to the requester instead of the regular delete deployment menu. This allows us to take over what happens when the server is being deleted and run a custom workflow before it's deleted. Again, we use Orchestrator for the external integration. So what happens is when the user clicks the delete deployment action that we took over in the UI, A predefined set of orchestrator workflows is executed that, among other, creates a standard change, deletes the DNS records, disables the computer account, and in the end retires the server in ServiceNOW. Lastly, the server is deleted from vCenter as part of the deployment process, and the user is informed by mail that the server is deleted and the corresponding change ID. And in ServiceNOW, the CI is now retired. So to sum up the primary outcome of the Windows deployment, self-service portal is available for deployment and day 2 operations 24/7. Security and compliance has been increased through mandatory SCCM client and agent installations. CMDB is always up to date and maintained at both deployment and decommissioning. And the deployment time has been reduced from days to 30 minutes. Linux virtual machines were becoming an increasingly popular request as well, and we wanted to be as much on par with Linux deployments as we were on Windows. Since SCCM is not usable for Linux operating system and the customer were using both Red Hat and Ubuntu, we had to come up with a solution that would support both of them. So the main challenge with Linux was to set hostname and IP configuration, as different Linux distributions configures IP configurations in different ways. We needed to provide unique passwords to local user accounts. We wanted to offer the option to add and mount disks based on user inputs. For non-domain join servers, we need to create local user accounts. We needed to configure SSH and remote access. And we wanted to be able to download and run scripts ad hoc when we need them, preferably based on user input to allow for as much customization as possible. Aria Automation supports Cloud-Init, which is a Linux configuration tool developed by Canonical for Ubuntu, but it supports almost any Linux distribution. It's basically a declarative configuration tool we use for configuring Linux operating systems that reads and processes a YAML file when the server boots the first time. In our cloud template, we have a cloud config section that will create a configuration file for use with Cloud-Init, based on the inputs provided by the requester. This will be made available for the virtual machine to instruct Cloud-Init on how to configure the virtual machine. This is an example of a configuration created by Aria Automation in a cloud template that the Linux server will process when it boots. The main feature in this file that is used with this customer is to install its updates and upgrades at boot. So this is run every time the virtual machine is deployed. It's always updated to the latest versions. We manage IP configuration, creating config files and applying them to the instance. Create local users and groups with temporary password that needs to be changed at first boot. And lastly, we execute late commands to configure the server according to business security or compliance requirements. Once the deployment is done, an email containing a temporary password for the user account we created when we ordered the server is included in the mail. The user is then required to change the password at first login, and the requested disks and disk group that were requested by the user are created and mounted, ready for use. The primary outcomes of the Linux deployments has been increased security, as all agents are installed and configured correctly every time. All defined processes has been followed and documented. Local passwords are expired and require a change at first login. Scripts are maintained outside of the solution and downloaded when needed. The latest updates are downloaded and installed at deployment time. And time to deliver has been decreased to about 10 minutes. If you want to know more about Cloud-Init, I have a session here at 2:30 on this stage. Any question? Yeah. Day 2 operations. Yes. Second day operations. Actually, I had a slide that I took out. The user has access to all day 2 operations in Aria Automation. So you can reboot the server, snapshot it the way you want to. Either by the built-in feature in Aria Automation, or you take over the function and add changes, ServiceNOW changes, and then execute it in VRA through API. So yes, they have access to day 2 operations as well. The application teams? Yeah, the users are application owners or service owners that requests virtual machines either for use themselves or for external partners.
Okay, because I was wondering about having to fill in IP addresses and subnets.
They have access to that. The reason they do that is they haven't got an IPAM system that would fill it out for them. If they had that, we would just integrate with that, and it would be filled out automatically. But you're right, this is not end user. It's the IT end users, application owners. Yeah, exactly. Yeah. Had you had an IPAM, it would just grab the next available IP, and then you would be good to go. Yeah. Okay. If any is using the rewards program, it's a QR code for you to scan. And if you have further questions, contact me or Thomas in the blue shirt, which is from the northern region of Jutland. He's in their internal IT. So you can just grab a hold of us, and we'll hopefully be able to answer your questions. Thank you.